Hello everyone, welcome back to my YouTube channel Maths by Aman Sarai. I hope you all are doing very well. In today's lecture, we are going to start with the basic concept of set theory. We will discuss four important topics in this lecture. First is set and its definition. Second is number of subset of a set. Third is power set. And finally, we will discuss our fourth topic, that is sum of two sets. These concepts are very important for MSc, CSIR-NET, also GATE. So without wasting any time, let's start my first topic, set and its definition. So a set is a well-defined collection of distinct objects. A set is well defined collection of distinct objects. So there are three important words in this definition. First is well defined. First is well defined collection. Second is distinct. Fourth is objects. So we discuss one by one. So firstly we discuss well defined collection. Well defined collection. Well defined collection means that we can already decide whether a particular object belong to the set or not. For example, A is equal to 1, 2, 3, 4. We clearly see that 1 is belong to A, 2 is belong to A, but 5 is belong to A. No, 5 is not belong to A. So my collection is well defined. We can clearly decide whether a particular object belong to A or not belong to A. So second thing is distinct. Distinct. Distinct means that the element of a set are considered without repetition. For example, A is equal to 1, 2, 2, 2, 3, 3, 3, 3. So we know that set don't allow repetitions. So we can we also return as A is equal to 1, 2, and 3. Then repeated element are not contained separately. So we can simply write is A is equal to 1, 2, 3. And one more word we discuss cardinality. This is my distinct objects. What is cardinality? The number of element in the set is known as cardinality. So for example, A is equal to 1, 2, and 3. So the number of element present in a set is called cardinality. So we denote the cardinality is we denoted the cardinality by cardinality of A. Therefore, Cardinality of A is number of distinct element in the set 1, 2, 3. So cardinality of A is 3. So this is basic definition of a set. Now let's move on the next topic, subset. So let's see subset. So we discuss about number of subset. Suppose a set contains n distinct elements. So write A is equal to A1, A2, A3 up to AN. So every element has a two choice. First, A1 is a subset. A1 is a including in the subset or not, है ना? So simply in the simple words, we can say every element has two choice. A1 is belong to the set A or not. A2 has two choice. The A2 element is belong to the set A or not. Also A3 is two choice. Belong to A, not belong to A. Also AN two choice. Also belong to A, not belong to A. For every element, we have two choice. Either we include that element in the subset or we do not include. So we see that 2 cross every element has a two choice. So 2 cross 2 up to n times, because we know that total element in the set cardinality of a number of distinct element in the set is a 1 2 3 up to n. So number of distinct element is n. So we try with the formula of number of subsets. So how many times 2r appears? N times. So 2 to the power n is number of subsets. So there are n elements. We have n such choice. So we have n elements. So we have n such choice. Therefore, the total number of subset, the total number of subset is 2 to the power n. Also we write 2 to the power cardinality of A. So for example, let understand this with an example. Okay. So let A is equal to A contains two elements A and B. Here we know that cardinality of A is 2 because number of element in the set 2. So cardinality of A is 2. We know that the subset are phi, singleton A, singleton B, and AB. And according to our formula, number of total subset is 2 to the power n. 2 to the power number of element in the set cardinality of A. So 2 to the power cardinality of A is 2. This is my n. N is 2. So 2 to the power 4. The number of total number of subset is 4. 1, 2, 3, 4. Here the formula is verified. So remember two things. First is the empty set is subset of every set. Remember, the empty set is subset of every set. Second is, and every set is a subset of itself, and every set is a subset of itself. Also, we write phi is subset of A, and A is also subset of A. These two facts are very important and you should remember it. Now we come to the next important topic, power set. So let's see. So the power set of a set A is the set of all subset of A. So the power set of A is the set of all subset of A. Also we write, also we denoted the power set A by power set of A is noted by P of A, and P of A also defined as a set of all subset of A X, such that X is a subset of A. This means the power set of A is the set of all subset of A. Also we know that subset of A is 2 to the power n. In simple words, if we collect all the subset of a set and make them into another set, another new set, that new set is called the power set. So we see in the example, let A is equal to AB. Also we know that its subset is phi A, B and AB. Notice one, therefore देखो, therefore the power set is, therefore the power set is, also we note the power set of A is power set of A phi A B, also we drive new set AB. So notice one important thing, the element of power set of A are themselves sets. For example, singleton A is an element of power set of A. AB is also element of power set of A. So kernelty of power set. So our next topic is cardinality of power set. We know that cardinality of A is n. Let let cardinality of A is n. A contains n elements. Then cardinality of power set of A is 2 to the power equal to 2 to the power n. So so I write the example A is equal to a B. Then find cardinality of power set of A. 2 to the power n is 2. So cardinality of power set is 4. So 1, 2, 3, 4. It is verified. Okay. Since the number of subset of A is 2 to the power n, the number of element in its power set is also. So we discuss a special case when A is 5. This is my special case. Then power set of A is also 5. So number of cardinality of power set of A is 2 to the power 0 is equal to 1. So remember, the empty set has 0 elements, but its power has 1 element. Okay. The empty set is 0 element, but its power is 1 element. Now let's move to our final topic for today's lecture, the sum of two sets. So let's see. So my next topic is sum of two sets. So we write definition: a plus b is equal to a plus b such that a belong to a and b belong to capital B. Let a and b two set of real numbers. Their sum is decided as a plus b. A is the element of a, b is the element of b. This means that we take every element of a, we take every element of a and add it is and add it to every element of b. So I repeat, every element of a and add it to every element of v. Let it's understand with the example. So we write a example. So given a is equal to 1 2 and b is equal to 3 4. So by the definition, every element of a and add it every element of b. So every element of a 1 plus 3. 1 plus 3 is equal to 4. 1 plus 4 is 5. 2 plus 3. 2 plus 3 is 5. 2 plus 4 is 6. Okay. So my set is 4, 5, 5, 6. But remember, this is a set. So repeated element are not allowed. So repeated element So repeated elements are written only once. So a plus b is 4, 5 and 6. This is my answer. So so I give a example. This is your homework. DYS. Do yourself. 1 3. A is 1 3. B is 1 5. Yeah, 4 5. Okay. So this is a simple thing. But I change something in the intervals. So I take A is equal to 1 2 and B is equal to 2 3. So same concept I repeat. 1 plus 2 is 3. 1 plus 3 is 4. 2 plus 2 is 4. 2 plus 3 is 5. So A plus B is 3, 4 and 5. 3 is 3 and 5. Also we write when one bracket is open, then interval is also open. Both side open brackets. So this is my final answer. Also you can written as, because 4 is also belong to in this interval. So let A is equal to singleton 2 and B is equal to 3 and 11. So A plus B is 2 plus 3 is 5 and 2 plus 11 is 13. So my interval is 3 and sorry 5 and 2 plus 11 13. This is my final answer. So your homework is device do yourself. First is 1 2 plus में 3 4. Second is 1 plus में 4 6. This is closed, this is open. Third is 4 6 2 3. These three examples, the in the three example, you do the answer in the comment box. So finally I repeat my whole concept in simple things. So firstly we revise the set. Set is a well defined collection of objects. Second is power set. Power set is a set of all subset of given set A. Also the quantity of a power set A is 2 to the power n. Also total number of elements is total number of elements is 2 to the power n. And finally sum of two two set sets is a plus b is equal to a plus b such that a belong to capital A and b belong to small b belong to capital B. So that's all for today lecture. That all for today lecture. I hope the basic concept of the set theory now clear to you. In the next lecture, we will discuss about functions and solve these all concepts. If you found this lecture helpful, don't forget to like the video and share to the channels. Thank you for watching. See you in the next lecture. So thank you.